Just a quick recap then before we do the next question. We have phosphate groups, two phosphate groups here that bond to the OHs here on a 2-deoxyribose, and the H and the OH are removed to make water. So I've removed them now, and the OH and the OH removed to make water, and then I just join them up, and that's how a phosphate joins to a 2-deoxyribose above and below to make the central DNA chain. How does a base join on? Well, a base uses the NH at the lower part of on the data sheet. Every base, each of the 4 bases, has got an NH at the bottom, and it's that bonds to this other OH here. So it's not on the main chain, it's branching off the chain, and that makes water. Remove it, and then if you join here, I've shown it removed with the H and the OH removed, and then you just join it together, and now I've now got a base joined on. And that then shows you the positions of the OHs that bond on the phosphate to the 2-deoxyribose, and the OH then that bonds to the base. And the position, the blue lines, the NHs, are where the bases join onto this OH and use an H with an OH to form a bond then between that carbon and each of these nitrogens. The other circles, the N's and the O's, the single N's and the O's, have got lone pairs on them. So you should draw lone pairs on those on your data sheet as you go into your exam. And then we use the bonding. I say jokingly that it's a little bit like Ghostbusters, where the streams can't cross. So you draw top to top, and then you go round one on each case, and you go round one again on each case, and that gives 3 bonds between guanine and cytosine, 3 intermolecular hydrogen bonds, and then from the top to the top between adenine and thymine, and then round one again on from adenine to thymine between an H plus and a lone pair of electrons. So you can see how all of those join up, and the streams or the hydrogen bonds don't cross, and there's bonds between lone pairs of electrons on O's and N's, and between the H pluses on this very polar bond here of the NH2s. So let's see how this works on this question here. So what is Y? Well, Y is a phosphate group. So we decided there's a phosphate group coming down here from the 2-deoxyribose, and what's going off this OH here? So this OH would have then so X is a base rather, the Y is the phosphate group. So I've got a phosphate group here, and the base X is the base is on the X part here. Now let's have a look at what this could be. So we've got to identify this. So we go back, and we're looking at a base that hasn't got any oxygens on it. It's got no oxygens at all. Well, guanine, cytosine and thymine have got oxygens, so I've got adenine. So this now is an adenine molecule here, an adenine base. So what does an adenine base join with? An adenine base joins with a thymine base, and the NH2 on the adenine joins to an oxygen, with the lone pairs of electrons on the oxygen being attracted with a hydrogen bond to the NH2, and the N on the adenine just around from the NH2 is attracted to the NH of the thymine. So what I would tend to do then is I would draw a thymine here. I'd have my data book alongside here, and I know that my NH2 on my adenine bonds to an O with lone pairs of electrons. I draw the lone pairs of electrons, and these two are going to bond then now. The NH2 on the adenine and the O on the thymine are going to bond. What else is going to bond? That N there on the adenine round from the NH2. That's that bond, that one there. I draw a pair of electrons on that, and that is going to bond onto my NH, this one here. So I need to flip this over, because that's bonding to that, and that is bonding to this. So I'm going to flip it over now. So I've got my O bonding to this, and my NH, which is there, is now flipped over here. I've drawn it backwards, and now I'll just spin it a little bit as well, and I'll put my lone pairs on, I'll put my delta pluses on, and I'll draw my hydrogen bonds. There are 2.